Hey, good morning. So let's get started with today's session around some inbuilt functions in Python. So I'll be giving an overview about how many different functions we have. Not every function that we have in Python, but at least most of the inbuilt functions, so that we can use them as when we decide. So far, we have looked at multiple uh, different scenarios. Like we have looked after data types, and then we have looked after how to manipulate those data types, how to convert data types from one data type to another data type wherever possible. And we have also covered the control structures, like how to write nested ifs, if else, if elif followed by else, and so on and so forth. And we have discussed a bit about error handling in Python. Okay. Just in case if you have missed, you can just always go back to the previous session and have a look. Before I start with today's session, I have some important topic to tell. Say, because we already know about lists and dictionaries and tuples, I'll just take a simple list. Say I have 1, comma 2, comma 3. As you know, that this is having a square bracket, and this is a list of defined length. When I call a list, it is called as an ordered elements. Okay. Why this is ordered? Because they have indexes. So you have the indexes that are present are like 0, 1, 2 in this case. Just in case if you have more number of elements in the list, of course the indexes will also grow. This is ordered elements. Same goes with tuples, and same goes with okay. The tuples also behave in a similar way. Only thing is that the tuple is non-mutable and the list is mutable. And you have something called as sets and dictionaries where they do not have any indexes. Okay, they are not ordered. Now, okay. Now, before we continue with functions, I have one small thing that we usually see. Say, for example, if I have, for some reason, I want to take a backup of this particular variable before I do further modifications. Okay. I just wanted to keep this as a backup so that I can compare after the modifications what are the changes made, and then I want to compare what has happened in next and what was happened after the backup thing. So how do I take a copy of this is by simply saying y is equal to x. For example, if you are done like this, okay? And now my intention is to append one number in x. So let us go back and see what is present in x, and also we'll go and see what happened to y. So if you notice, both x and y have the same set of elements. I have used dot append on x. I did not use dot append on y. By default, what generally happens is when you declare a variable, okay, say this is your RAM. RAM is defined for storage, and when you declare a variable, this x is sitting somewhere. Say for example, here is your x. Okay, this is having it some memory. Now, when I say y is mapping to x, or say x is assigned to y, then y is also referring to the same memory object. Okay, they are referring to the same memory object. Keep it in simple terms. Okay, so whatever happens in this memory applies to both x and y variables. Say if you don't want this thing to happen, then we will use something called as copy. Let me just clear my drawings. All right, so if you don't want this thing to happen, I want y to be as such. I don't want any changes there. So I'll copy the house. So same thing. But one small thing which I'll do is I'll import copy, and I'll say x should be copy of x. What you're trying to tell the code is don't refer to the same memory, create a different memory of what x was having. So internally, what happens is previously you had RAM like this, you had x here, and you're saying that whatever value that is present in x, copy and paste it in a different memory. Now, this is your y. Now, x and y are referring to two different memory objects, right? And then whatever operations that you do in x will not apply to y. right? Let us see. I'll just say y is equal to copy dot copy of x, and then I'm appending 4 to x, and then when I print it, you notice that the y is in the last print, so the y is as such. It did not have any changes. So whatever you noticed just now applies to most data types in Python. Say, for example, if you take if you take dictionary, say, for example, I have a dictionary. How you denote a dictionary is by using curly braces. I say A, this is my key, and the value is 1. This is my key, and the value is 2. This is my key, and the value is 3. A simple dictionary, okay? So key value mappings in X, and again, this is unordered, but you can access the value by calling it key. Say, for example, I'm just telling what I have told earlier. So if you want to know what is value stored in A, you can simply call X square bracket of A, then you'll get the value 1. So now what I'm doing is Y is equal to X, and then I'll say X of C. I already have C, right? I'll say D is equal to 4. I'm just adding a new key and value to it, and then I'm printing both X and Y. As you notice, it is before, because it is referring to the same memory, it is applying those changes to both of them. So just in case if you have this thing and if you don't want the changes to occur in both the data types, then you can use copy.copy, right? And when I do this, you can notice that the Y did not change. All right. From the technical words point of view, whatever we did, this is called as deep copy by default. And what we did here is a shallow copy. Just keep this in mind, because whenever we are writing long programs, and we tend to see what are the changes that has happened before and after, and we tend to take backups of variables by simply assigning that variable to some other variable, and then we try to change the variables, and we notice that the change is occurring in both the cases. So this is very common thing that we should keep in mind: deep copy and shallow copy. So whenever you want the changes should not pass down to the new variable, always go with deep copy. The same goes with pandas also, right? Of course, the pandas part we have not covered yet, but I'll just reiterate the same class again when I'm talking about pandas. But so far so good. You have understood how to deal with copy and deep copies. Now let us go to some inbuilt functions. Okay. Now in the previous session we have already seen couple of inbuilt functions. Like you have seen this print. Print is an inbuilt function. We have also seen something called as sorry. We have also seen some other functions like length, isInstance, type. What else did we cover? I think, yeah, these are the common functions that we have seen. So we'll look at some more inbuilt functions that are present in Python. Okay. The first to deal with is print. This is the easy peasy function that we have in Python. Okay, you put whatever inside the print function, it'll throw back the same thing to your console. Now what you see below here is the console output. So because this is a notebook, you have the console output just below the cell. Just in case if you are running a Python script, then you would be seeing all your outputs in the terminal. So this is my terminal. How you go to terminal is by clicking on terminal, and when you go to new terminal, you will have the terminal here. So when you run the code here, say for example, I have Python test.py. So test.py is nothing but my Python file, and whatever prints that I have in test.py will occur in this part of the console. Okay, so for as a startup point of view, we don't have to go to Python yet. Let us stick to Jupyter Notebook so that it is very easy for you to execute line by line, and then you can always take it to the complicated part later. Okay. So as I said, like print is a very easy function where you pass all the values to it, and it'll throw those values back to the console. Now, if I can pass one value, like in this case hello world is one value, and or else I can also pass two values to it. Like now this is in this case I have hello world. This is a built-in function, so if when I pass two values to it, it will pass two values. So it is dynamic. It is not defined to set length. Say for example, it is not consigned to only five variables. Only you can allow only five variables or six variables. You can send any number of variables to print function, and it will accept all of them, and it will simply print them. Okay. A couple of things that we have in print function is separator. Please note that these are very basic classes, so I don't have to tell you in a very slow manner. You can easily pick up. Feel free to pause the video, try your own in your own console and see if it works or not. Uh, but this is a very simple concept. We should not stop here. We have many more complicated things to discuss. So if it is easy, I think we can knock it off in a shorter time. Okay, in print, we have something called as separator. So just in case, if you, in this case, see, I do not have any separator. I have a comma here, but in the output, there is no separator. With a single space, it was giving all the uh, variable outputs. So by default, the separator is space. So you have a space here, but I did not put space in the string. I did not put space in the string. So by default, the separator is space. I can change or override the separator by using this keyword. This is called as a keyword. When I say separator is equal to a pipe symbol, I have a space, pipe and space. When I say this, you notice this pattern, whichever pattern is present here, is coming here. Okay. And when we do this, we can, okay, when we also have one more print here, say for example, I have I have added one more thing. So if you notice that, you will get this pattern one more time. Okay, as simple as that. Now you can use a simple for loop to print. Say for example, I have a tuple here. The tuple is having 1, 2, 3, 4 values. And what I'm trying to do is I'm trying to take one element of that tuple and then I'm printing it. So by default, what happens is every time the print function is called, it adds in a new line. Say for example, in this case, one is the first element. It prints one. It go back to the next element 2. When it goes to print 2, it will not print in the same line. It will print in the new line. So by default, the end is nothing but a new line by default. So generally what happens is it happens internally. By default, the keyword is this in print, end is equal to slash new line. So when I execute this or when I execute this, it is the same output. Okay. So separator is one keyword that we have come across, and end is another keyword that we have come across in print. So you can, instead of printing all this in new lines, I can also print it in the same line by using a different pattern. So in this case, what I did was instead of putting a new line, I said that the end should happen with pipe symbol. So this is how it converts the print to single line. Okay, just keep this in mind. If you want to use, you can use a separator as well as end to modify the print statements. And the second function, inbuilt function that we saw was type. So type is to see what kind of variable that you have declared. Say for example, I have hello world. It says the type is string. So just in case, if I can call one function in another function, say for example, print type of hello world. Okay, when I do that, it returns in a more beautified way. It says string, class string. Okay, and then of course we have seen this, how we convert the data from one uh, data type to another data type. So we have used print followed by type here. You see it is a string, and then we are using the int function to convert that string to an integer. And then when you have print the type of x, it is integer. Okay, I think that is quite obvious. Just keep in mind that whenever you're using operands, like any mathematical operands, the data type should match. At least it should be integer and float for applying any mathematical operations. Okay, and we have already covered all these sets, different types of conversions. You can try out all these things if you want to try. There is one other function, inbuilt function, which is very important, and we use on a regular basis. Say, for example, if you have multiple conditions, right, and you want to make sure that if all the conditions are met, only then you should continue your part of the code. Say, for example, so when I say there are multiple conditions, each condition is returning whether it has passed or failed. If it is passed, it will return in true. If it is failed, it is returning on false. Say I want to apply if at least one condition is matching, then I want to continue my program. So how do you do that is by using any. So for example, okay, let us take another way. If I want to see that all the conditions are met, okay, condition one is true, condition two is true, condition three is true. If all the conditions are true, then only I should continue my code. So how do you check if all the conditions are met or not is by using this all function. The syntax of all is nothing but all followed by the list of values. Say here in this case, the list of values is but nothing but the list of booleans. Okay, so all expects that if all the data types are of true, only then it will go to true. If any of them is false, it will return in false. Say for example, if I have true, true, false, and true, then it will return as false. It is obvious, like because it failed in one condition, you don't want the code to continue. That is how you can use all. Similarly, if you have all of them are true, then also it will be true. Say, for example, if we have all of them as false, let us see what happens. Okay, we have false here. Let us take one more false. Okay, false. So it should, by default, what it looks for us if all the conditions are met or not. Like this can be a case when we are trying to use pandas. So just keep this in mind. This will be helpful in our coding purpose. But what all does is it checks if all the conditions are matched or not. If all the conditions are matched, then it will return in true. Say, for example, if you have a logic like this, okay, because we have already discussed about conditional statements. If I'll say like this, sorry, if my conditions, my bad again, if all my conditions are matched, then I want some part of the code to continue. You can have n number of lines here based on the logic. So you can write like this. Okay. The same goes like this. If you do not want this to continue, if you do not want this code to continue when there is a false, you can use like this and say, let us say one of them is false. And in this case, it will not execute. So you don't have the print here. So that is how you use all. In some cases, you might also have a condition where at least one condition is matching. So in that case, you will be using any. In any, it checks for at least one true, irrespective of which index it belongs to. It is not bothered about if the first one is true or the second one is true or the third one is true or the last one is true. It doesn't bother about that. What it bothers is at least one true in the in the set of boolean values. So if it finds at least one true, it will return true. Okay, irrespective of index. And the same goes with false. If all of them are false, of course it will be false because none of them is true. Okay, in both cases. Okay, this is how the all works. I think we have discussed about boolean. We don't have to worry about all this. All right, in dictionary we have a set of things like say for example, we have a simple dictionary here and we have keys. 0 is apple, 1 stands for orange, and when I say my dot keys, it will print only the keys. Like in this case, 0 and 1 are the keys. Now, when I go and print all of my dict, because they are 1 and 2, for example, 1 minute. Yeah. Say, for example, I have taken one more dictionary. In this case, you have seen one 0, right? And one 1. Okay. I'll take one more dictionary, my dict 2, and I'll say 2 is for apple and 1 is for orange. When I say all of my dict, it will say true, because it is not an empty dictionary. But on the other hand, if I pass an empty dictionary, all, if I pass empty dictionary like this, even in this case, it is showing, but yeah, it is having some value, so it is not going. But you should not use all like this. The best way to do is check if my dict, I'm just checking if the dictionary is empty or not. So in this case, you did not get the print. So my dict by default, when you check for if it sees it is an empty value, and it treats that as a empty boolean, false boolean. So this condition doesn't pass, and then this print is not coming. Okay. And it should be maybe 1 minute. Maybe we should check for keys. Just a minute. Yeah. So if you check for keys specifically, then it goes and checks it. There is a 0 here. That's the reason why it says it's false. But on the other hand, if you go and say, uh, in this case, like we have here, right? I have taken my dict dot keys, then it will return in true. Okay, because you have 2 and 1, you do not have any zeros. That's a difference. But anyways, I think I have not used any such kind so far. Uh, this is just to show how the function works, but on maybe in a real world, you might not have such requirement of checking all in dictionary.keys. Anyways, so the next function what we have is sum. Sum is also an inbuilt function where you pass some iterator to it. Say, for example, we have list. In under list, you have couple of elements, 1, 2, 3, 4, all of them belonging to integers. So when I call this sum function and I pass this list, it'll sum them up and it'll throw the output. Same goes with float. You can add one more float in the list and it'll throw the output. Okay. And we can also have tuples. I said, if you should have some iterator, when you have an iterator, then it can sum them up and throw the output. If you know, in the previous class, we have tried to add one integer and a string, and then it throws an error. It says that integer and string cannot be added. The same applies to some function. Okay, the same applies to some function. What happens is, like, when you pass one string in the list, and when you try to add them up, and you get the same error. Sum. Okay, unsupported operand. Similarly, when you apply two same data types, say for example, if I have taken strings and I'm using some function, it will not work, because it assumes that it should be of integer or float data type. And if it is checking that one of them is string, again, it will say the same error. But on the other hand, you can directly go and apply the operand, because here in this case, it transfers, because both of them are string data type. It will simply concatenate them, and it will throw the output as 1, 2. Please notice, this is a string. It is not a number. Okay. And in list, you also have a couple of other functions like min and max. So what you can do is, like, if you can say min of 1, 2, 3, 10, -5, for example, and it will go and say it is -5. So it's an inbuilt function to iterate. You will again pass some iterator to it. This is called as an iterator, where you can pick element by element, and then in that iterator, you can go and choose which is the lowest number. Okay, and we also have seen yeah, this is the minimum function that we have seen, and maximum also works in the same way. If you have max, it will tell which number is max in that particular list, and it will throw the value. The other function that we saw was length. It will tell how many elements are present in your given variable. Okay, this is one thing. Again, when you say length of mydit, it will look at how many keys that you have, and then it will throw the number of keys. You can also look at what is the length of dictionary dot values or dictionary dot items. The same thing. Let us have a look at how to handle a simple for loop using iterator. Say, for example, I have XYZ as a list, and I'm writing a for loop now to pick one element and also increase my counter. So by default, let us say the counter is 0, and I'm taking one element at a time. Okay, I have a bunch of apples. I'm taking one apple at a time from the basket. So when I take that, I will print what is my counter. Initially it was 0, so for the first element it will be 0, and then I'll also print what is the element that I have chosen, and then I'll increase the counter by 1. Okay, so when I do that, uh, for the next element, the counter will become 1. So when it goes and prints, it will become 1, and the second element will be y, and then after it prints y, then again it will increase the counter. So when I run this loop, you can notice that counter is 0, element is x, counter is 1, element is y, counter is 2, element is z. Okay, same goes with whatever you did so far here. You can use an inbuilt function called as enumerate to achieve this functionality. Okay, because we have more number of line of codes here, right? This line of codes, whenever you have a need of tracking the index, you can assume this as an index 0, 1, and 2. I initiated my counter with 0, I increased it to +1, I increased it to +1 here also. The same thing can be achieved by using enumerate function. So enumerate, again, it takes iterator as an input, and every time it picks an element, it also picks the index at which that element is present. All right, say for example, in this case, when you have xyz, so in this case when you have xyz, when you pass this to enumerator also picks the index. Okay, so how you can pick index and value is by using two elements. Previously, the for loop was having only one element, see, for element in X. But in the case of enumerator, when you take one element out of enumerator, it gives two. I mean, two attributes to it. One attribute is the index and another attribute is the value. So I'll say the first one is index and the second one is value. So when I go and print index, what is index? I'll go and print in the index, and what is element? I'll go and print in the element. So when I execute this code, it'll show me both the index value and the value of the element that is picked. Understood? I mean, that's an easy way. And we have also something called as eval. Eval is something to convert a mathematical expression in string format to the actual value. Say, for example, I have a string which says 5 plus 6. Okay, note that it is in string, and when I go and print x, you will get this. But the same expression can be converted to mathematical expression by using eval. So what happens is eval will simply remove the single quotes and it will execute this code. So it'll convert after it removes the single quotes, then it will execute as 5 plus 6 and it will throw the output. Okay, this is eval. Same goes with, like, you can eval like this also. Say you have input x is equal to sum of 5 comma 6, which is in string format. When I go and eval x, it will throw the output of this particular expression which is in string. I think we have already seen each instance. I don't have to explain it one more time, but you can practice it. It is just checking for what kind of data type. I mean, whether it is checking whether the given variable is matching the data type or not. Say, for example, 5.6 is a float. I'm just checking whether 5.6 is integer or not. And it will throw the output as false. If it is matching, in this case, if it is matching, it will throw an output as true. I think each instance we have already seen, so I will not tell you about that. Next is range. So range, again followed by the syntax for range is the start point and the end point. Okay. And by default, what range does is it increments the number and it keeps on adding one number to the start point until it reaches the end point. Okay. So when I go and print, say for example, if you go and say range 0 to 10, it will not show because it is an iterator. You will have to use a for loop. So for x in range 0 to 10, I want to print x followed by some pipe symbol. Okay. So when I do that, just notice that it will include the 0, but it will exclude the 10. So once it reaches 9, it adds one more value, which becomes 10. Because 10 equals 10, it will not print it. Okay. Just keep that in mind. It will, like, if you know the number diagram, right, this will be like 0 and this will be like 10. So whenever you have a parenthesis here, it will not include it. It will include till 9. Just in case if you want to print till 10, maybe you can increment the number to 11. Okay. I can also do the same thing. Instead of picking it at every value, I want to pick every alternate value from 0. So what I'll do is I'll say 0, 10, and this will be the incrementer. The 2 is called as an incrementer. So when I do this, it will print all my even numbers 0, 2, 4, 6, 8. Say if you don't want to print all the even numbers, I want to print the odd numbers. So what I'll do is I'll simply change my initial value from 0 to 1. And when I do that, it will print all the odd numbers. Again, it will not go till 10. Okay. Here also it will not go till 10. Here also it will not go till 10. And you can also do the same thing for every third element. You can do this by picking every third element. Okay. Just keep this in mind. So whenever you have a scenario that you want to pick every alternative elements, you can use range followed by this incrementer. Okay. You can pass an incrementer to it. And then we have something called as sorted, which will just sort the elements in an increasing order. This sorted will work even for different data types. So for example, you have sorted, and inside sorted, you have a different set of variables, say A1, B2, 1, 2, sorry. I'll take one Boolean data type, and then I'll also take 1A as one of my input. And then when I do this, see, when you have a mixture of data types, it is having an issue. But if you go and take all similar ones, sorted A, B, C, like again, like let us take Z here, and let us take 1A, ZA, and then let us see what happens. So now in this case, it has sorted in a proper way. So whenever you have a mixture of data types, the sorted function might not work because of it fails to understand between integer and string. But if you have a similar data types, all of them are similar data types, all of them are string. In this case, what it does, it will pick numeric alpha characters as a first one. Okay, followed by your alphanumeric cases. Maybe if you have some dollars here, let us see what happens in the case of dollars. Okay, so when I do that, see the foreign characters are getting printed first, followed by the numeric alpha, followed by the alphanumeric. Okay, just keep that in mind. And we also have something called as reversed. It will just reverse the output. So I have taken an input of 1 to 3, it has simply reversed to 3 to 1. So just in case if you want to reverse the order of elements, you can always do that by using reversed. I think error handling part we have already covered, so I'll not explain that one more time. So in error handling, you're simply using try and accept. I think if you have missed it, you can simply go back to my previous session and just have a look, or you can simply execute this code and see. I can upload this file for you so that you can run this and see. Okay, what it'll generally do is it'll just execute this. If it fails somewhere, it'll capture the error as this particular variable, and it'll throw the output in this. So that whenever you have an error, you can say a request occurred. See whatever error that you have here, right? It will be printed here. Due to, where is due to? Yeah, due to can only concatenate string, not integer to string. Okay, just keep that in mind. I think we have already seen about try accept. I will tell about user defined functions in my next session. As of now, we are dealing with only the inbuilt functions, so I'll stick to it. Uh, Classes also I will tell in the next session. Okay, I think we are good for today's session. I will continue the class on user defined function as well as classes in my next session, so that we can run one complete part of end to end, how to deal with multiple data types, how to deal with error handling, how to write our own functions, how to write our own classes, and how an object can pass from one function to another function, and how we keep on using it to achieve our functionality. Okay, so just you can reach out to me if you have any questions around this inbuilt functions, or any of the previous sessions that we discussed so far, and then we can take further more classes in this category. Okay, I think we are good for today. Thank you so much.